I'm Harper. I have 2 degrees, so an undergraduate and graduate bachelor's and master's in science, in engineering, in computer science, focusing in artificial intelligence from Stanford University. And then I was at Meta for 4 years working on building machine learning systems there while simultaneously getting my master's at Stanford. And then I left and I was founding engineer at a startup. And then I became head of AI ML at a company that was acquired by NVIDIA. So at that company, the startup, ultimately that was acquired by NVIDIA. While I was there, I started teaching AI on X. I was doing these fine-tuning guides and those blew up really fast. And then I started on Instagram and I was teaching for a more broad audience. So on X, it was, coding guides for fine-tuning models, which is when you actually go in and change the parameters of the model. But then on Instagram was more broad kind of AI inner workings knowledge. And yeah, I've been doing that ever since. And it's been about 1.5 years now. So if you're new here, welcome. Hallucination from a math perspective. Why is it when I ask a large language model math questions, it does so poorly? And, it'll like make up random numbers. Like, for example, if I have a case ID, it'll make up like random case IDs that aren't real for, legal matters and things like that. Why does that happen? This is a great demonstration of why hallucination happens. So the reason that large language models tend to need to be augmented, either trained specifically on math problems or augmented with like a calculator, is because exactly what I was talking about with them being probability-based machines. So when a large language model is trained on the internet, it has an enormous amount of data that it looks at. It learns the relationships between words on massive amounts of internet data. With math, first of all, there isn't as much training data. There's just enormous amounts of text data on the internet. And also one thing with text data is that you can create even more data from it. So if I have the sentence, hi, my name is Harper, and I want to use that sentence to train a model, I could cut it up into every single piece of that. So I could say I could teach the model to predict my after getting high. I could teach the model after getting the token high. I could teach, and that could be a thing where it's like the input is high, the output is that it should predict my. Then I could also cut it into, given hi my, it should output name. And then I could also cut that into hi my name, and then it should output is. And then hi my name is, and then it should output Harper. And so that's I don't remember, but that's 5 training examples just from that sentence. So if you're looking at the entire internet, it's enormous how much training data you can get from that. And that's why these models are just exceptional, because they really do understand the relationships between words in a really kind of nuanced and complex way. With math, there isn't that kind of first off, you can't really cut it into that kind of probability, right? It doesn't have a concept of multiplying things. It doesn't really know how that works. It's predicting okay, if I get 5 and then I get a time symbol and then I get 3, then the output should be 15. Okay, maybe that's one example. Maybe that's one training example. But then imagine, cutting that up. It's okay, it gets 5. Should it predict an X, like a time symbol? Should it predict a division? Is 5 times 3 more likely than 5 times 2? The probabilities of math problems doesn't hold up here. It's okay, 1 plus 1, it should be able to guess 2, because that's such a common math problem that you see on the internet. But, is it gonna see the example 653.4 times 896.72 and know how to solve that? It doesn't. Again, it's outputting based on patterns it's seen before. And with numbers, it's that doesn't really hold up. What math equation is more likely than another? And is that really what we're solving for here? No, it's math is a set of rules. It's not really probability based. The output isn't probability based. And so with these case numbers, so say it receives, 10,000 examples of legal documents that all have different case numbers. Okay, it'll probably get the length of the case number right. If they all have the case number, it'll predict, okay, I should output, say they're all 10 digits. Okay, it'll output something that's 10 digits. But because there's so many different combinations of digits, for any given digit in those 10 slots, it's just outputting a probability. It's just choosing a digit from a probability. So it's not going to choose J if it's always, numeric, not alphanumeric. It's going to know the probability of J is 0. But the probability of any token between 1 and 9, 0 and 9, probably pretty equal. And so it's going to make up, because it's a probability sampling machine, for every digit, it's going to just sample from like 0 to 9, you know? But again, it won't like choose a random token like high. Again, tokens are fragments of words, so it's possible that high is its own token. But again, yeah, it's going to know it's a number, but it's not really going to know which number it is. So, and that goes back to the fact that they don't actually have access to specific data sets. For example, these legal cases that it was trained on. It doesn't actually, once it's been trained on it, it doesn't have access to it anymore. It just uses it to learn how words relate to each other, but it doesn't have like photographic memory, you know, in the same way we don't. Like you might look at a bunch of case numbers and know, yeah, I mean, they have 10 digits and they're always digits. But could you cite a random case number of a like legal document that you read? Probably not, unless it was a very special document that you looked at a lot of times, you know? So I hope that explains why hallucinations tend to really happen with math problems and why large language models don't do well on math, because it's math. It's not language. It's like math is a set of rules, and AI large language models learn from examples. And so you would have to have like infinitely many examples for every single possible math problem you could ever do for it to do well. So I hope that helps.